how can we apply this in these kind of applications? Now, as we apply them off and on, quite very often, things would become clearer. But as I would always keep on exhorting you to do this, or rather coaxing you to do this, that whenever you have this kind of, you're going through the video and you need to solve these kind of sums, always keep a rough book or a piece of paper in hand with a pen or pencil. Whenever you get the questions, don't be tempted immediately to check what the answer. Work them out and check. And in such cases, constant repetitions would not be needed. A few attempts going through the video will give you more effective output in your concepts, and all the cobwebs will be clearer in a much more effective way. Coming back to our question, the question says, if P and Q are the roots of x square plus 2x plus 1 is 0, then the values of P square plus Q square will become what? Okay. Now here, if you see, we want to find the value of P square plus Q square. Now P square plus Q square is nothing but P plus Q the whole square minus 2PQ. Right? Now, if you see, we want to find the sum of the roots, that is P plus Q. If you remember, it is going to be nothing but minus B by A. Now, if you look at this equation, here B is going to be 2. AX square plus BX plus C is 0. So, this is going to be 2. So, P plus Q is going to be minus 2 upon A1, which is minus 2. And C, PQ is nothing but C by A. C in this case is 1. So, 1 upon 1, 1. So, now we know this. Substitute these two values in this equation. So, we get P squared plus Q squared is equal to P plus Q the whole square, that is minus 2 the whole square, minus 2 into PQ, that is minus 2 into 1. So, we get 4 minus 2, which is 2. So, P square plus Q square is going to be 2. So, among these options, simple way of doing it, we're just using A square plus B square. Only thing is, be clear that A square plus B square is not the same as A plus B the whole square. So, just for our confirmation, we will observe what the value is. Yes, it is 2. So, what do we have here? The next situation or the next problem we have here is, if one root of the equation Px squared plus Qx plus R is equal to 0 is R, then other root of the equation will be what? So, alpha is equal to R. What would be beta in terms of R or whatever it is? Now, we know alpha beta is nothing but C upon A. Alpha beta is C upon A. Now, as per this equation, we have, so if you look at this particular equation, alpha is R, beta we do not know, C in this case is R, and A is P. So, R, when you divide both sides, you get R beta is equal to R by P, and hence you get beta as 1 upon P. That means if alpha is R, that is one of the roots is R, then for this equation, since C by A is alpha beta, we just have to substitute the values and you're getting beta. Here, another possibility is you could even say alpha plus beta is Q. But then we are stuck up, we have reached a dead end. Beyond that, we don't know the condition, because you'll end up getting in that case that R plus beta is equal to Q. So you'll end up getting beta as Q minus R, which is not around the options over here. Okay, so beta can be Q minus R too, but here we have is something else. So we have beta is 1 by P. So the other root is going to be 1 by P. We just substitute in simple process that alpha beta is C by A. And yes, the other root is 1 by P. So from here, where do we go? The next one we have is this. Okay, this was similar to the question which we did earlier. If alpha, beta be the roots of the equation so and so, of the equation 2x square minus 4x minus 3 is 0, the value of alpha square plus beta square. Now, if you look at this equation, A would be 2, B would be equal to minus 4, and C is minus 3. Now to find alpha square plus beta square, if you see alpha square plus beta square is nothing but alpha plus beta the whole square minus 2 alpha beta. Now alpha plus beta the whole square is nothing but minus b by a the whole square. Minus 2 alpha beta is minus 2 into c by a. Now this will turn out to be minus b by a the whole square, that is minus of minus 4 upon 2 the whole square. Minus 2c by a, minus 2 into minus 3 by 2, and hence you end up getting that minus 2 alpha beta, which will turn out to be 2 square. This gets cancelled, of course. This will become minus 4 by 2, 2 square 4, and minus of minus 3 is plus 3, so 4 plus 3, and we get it as 7. So alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta, which is minus b by the whole square minus 2c by a, and we are getting the solution as 7 here. So among these 7 is the option we have. We did a similar sum earlier, okay, where the equation was of a different type. So we got the solution as 7, and yes, that's what we have here. Now furthermore, okay, now here you have a situation that if one root of 5x square plus 13x plus p is 0, be the reciprocal of the other, then the value of p is what? So that means alpha is equal to 1 by beta. Alpha is equal to 1 by beta. Now if you look at it, A is 5, B is 13, and C is. So here we have one root, if it is alpha and the other root is 1 by beta, is beta, that means alpha is 1 by beta. We can even interpret it this way, that one root is alpha and the other one is 1 by alpha, or one root is beta and the other one is 1 by beta, either ways. Now again here we want to find the value of p, so we can either say alpha plus beta is minus b by a, but that doesn't feature p, so we need to take anything which involves c. So it's going to be alpha into beta, that is the product of the roots, is c upon a. Now c upon a in this case is p by 5, and alpha and beta, that is product of the roots, which you take it as alpha is equal to 1 by beta, means you take beta into alpha, which is whichever, 1 by beta into beta. So you get alpha is 1 by beta into beta is p by 5. This gets cancelled, so that means 1 is equal to p by 5, which means that p is equal to 1 into 5, 5. So if the roots are reciprocals of each other, c by a, which is alpha by beta, turns out to be 1, and hence p by 5 is 1 and p is equal to 5. So our option is going to be p equal to 5. And yes, we do have it right here. So they're all simple problems, but application as to which part would we use, would we be using alpha plus beta or alpha into beta, we need to understand that. Now further, now here we have something like this. If sum of roots of the quadratic equations ax square plus bx plus c is 0 is equal to sum of squares of their reciprocals, and b square plus upon ac plus bc upon a square is equal to what among these? Now here we will actually have to solve it. Now sum of the roots. So suppose the roots are alpha and beta. Then alpha plus beta, which is the sum of the roots, is, that is equal to sum of squares of their reciprocals. That is 1 upon alpha square plus 1 upon beta square. This condition has been given. Now you need to express this whole thing in terms of b by a, c by a, and terms of that. So this will be actually equal to, if you simplify this will become alpha square plus beta square upon alpha square beta square, which is the same as alpha beta the whole square. So you get alpha plus beta is equal to this. Now again here alpha plus beta is nothing but, this can be written as alpha plus beta the whole square minus 2 alpha beta upon alpha beta the whole square. Now, if you look at this equation, now we have everything in terms of alpha beta and alpha plus beta. Now, why do we do that? Just a reminder, because alpha plus beta is minus b by a and alpha beta is c by a, and whatever is the requirement is in terms of a, b and c. Now, since the quadratic equation is ax squared plus bx plus c, alpha plus beta is minus b by a. This would be alpha plus beta the whole square, that is minus b by a the whole square, which is b square upon a square, minus 2 alpha beta, that is minus 2c upon a, upon alpha beta the whole square, that is c upon a the whole square, which is c square upon a square. Now we need to draw a line just to understand. So we get minus b upon a, and this numerator, the LCM is a square. A square by a square is 1, and this becomes b square. A square by a is a, so you get minus 2ac divided by c square by a square. And this, if you simplify, will give you b square minus 2ac upon a square into a square by c square. So we get something like this. The rest is just cross multiplying and doing it. If you cross multiply, you get b square minus 2ac upon c square. So it will become minus bc square is equal to a into b square minus 2ac. This on simplification becomes minus bc square is equal to ab square minus 2a square c. Now if you look at it, we have something like b square plus ac plus bc by a square. So what is expected is a number. So we'll collect all the ab square, bc square and all, take all the terms because we need positive. So we convert the everything to be positive. So you take this to this side, you get 2a square c is equal to ab square plus bc square. Now we need b square upon ac, which we would get if you divide by a square c on both sides. So if you divide by a square c, you get 2 is equal to ab square upon a square c plus bc square upon a square c. Now here a and a get cancelled. Here one of the c and c, and ultimately you're getting b square upon ac plus bc upon a square. So ultimately you're getting b square by ac plus bc by a square. The value is 2. Now as I told you, you have to remember these things, interpret it and express everything in terms of b, a and c, because the whole final solution has been given. The value of the expression whose value has to be found out has been given in terms of b, a and c. So immediately you should send a trigger that we need to express the whole thing in terms of alpha plus beta and alpha beta, right? The rest is all simplification. And of course here comes the hitch. How do we know what has to be done? We need the whole expression positive, so collect all the positive terms to one side and then you divide it and you see the terms getting cancelled and you're getting the value of whatever is the expression is 2. And hence the value of this expression is 2, and that's what we have here. Value of the expression is 2. And from here, furthermore, we have the next one, which is going to be, okay. Here we have a situation which says that if alpha and beta are the roots of x square is equal to x plus 1, then value of alpha square by beta minus beta square by alpha is what? Now here you need to be a little careful. One is we have to see that all the equation has to be brought to the standard form. So we have x square is equal to x plus 1 would become minus x minus 1 is 0. The right hand side has to be equal. So now as a result of it, you have a is 1, b is minus 1 and c is also minus 1. Now you have been asked to find the value of this. You have been asked to find alpha square by beta minus beta square by alpha. If you see, this is going to be alpha cube minus beta cube upon alpha beta. Now we know alpha beta is C by A, so we will minus 1 by 1, right? So we can substitute right now here itself you get, now because we don't know what alpha cube minus beta cube is, so alpha cube minus beta cube upon minus C by is equal to C by A, which will turn out to be alpha cube minus beta cube is equal to C by A, that is minus 1 by 1 minus 1, right? Now this, if you simplify using A cube minus B cube, remember we should not mix this up. A cube minus B cube is A minus B, that is alpha minus beta, into alpha square plus beta square, and since it is alpha cube, this one is negative, this will become plus alpha beta. Now again here we know only the value of alpha beta, so which can be taken as minus 1, but now here comes alpha square plus beta square, and this is alpha minus beta. So what we need to do is we need to write this alpha beta minus beta as alpha minus beta the whole square, so that we can express it in terms of alpha plus beta the whole square, because we know alpha plus beta is nothing but minus B by A. We don't know what alpha minus beta is, and this is in the first bracket. Second bracket would become alpha plus beta the whole square minus 2 alpha beta of this plus this alpha beta, and we get it. Now remember what we did, that alpha plus beta the whole square minus alpha minus beta the whole square is nothing but 4 alpha beta. So this has to be expressed in terms of the same. So this is going to be nothing but alpha plus beta the whole square minus 4 alpha beta. A minus b the whole square can be written as a plus b the whole square minus 4ab, because if we expand this, this will become a square plus b square plus 2ab minus 2ab will give you alpha minus beta. Now hence we have all these things. This will now become alpha plus beta the whole square minus alpha beta. Now hence once again we have alpha square by beta minus beta square by alpha, and you get alpha cube minus so and so. And remember, this whole thing is minus because there was a minus over here, so the minus carries forward over here. It is going to be alpha cube minus beta cube, which will be same as minus of alpha minus beta, which is alpha cube minus beta cube of minus 1. Now this minus 1, I've written it as minus the whole of this. Now alpha minus beta, we do not know the value, so we need to express it. Since we want it in terms of ABC, we write it as alpha minus beta the whole square and its square root, which is alpha plus beta the whole square minus 4 alpha beta minus so and so. Now here alpha plus beta the whole square, alpha plus beta the whole square is minus b by a, so minus of minus 1 by 1, which is 1, so that is 1 square, minus 4 alpha beta. So here we'll just calculate alpha plus beta, which is going to be minus of minus 1 by 1, which is 1, and alpha beta is c by 1 minus 1 by 1 minus 1. Now minus 4 alpha beta means minus 4 into minus 1 into alpha plus beta the whole square, that is 1 square, minus of alpha beta, so minus of minus 1. So this one simplifies and becomes minus of 1 plus 4, that is 5, into 1 square plus 1, that is 2. So this turns out to be minus 2 root 5. So the value of alpha square by beta minus beta square by alpha is nothing but minus 2 root 5. Once again, as I told you, first expression has to be simplified and express everything in terms of minus b by a and c by a. Okay. So our solution is going to be minus 2 root 5, which is right. The next that we have in hand is this very simple thing. You have a question which says that if 2 plus root 3 is a root of a quadratic equation x square plus px plus q is 0, find the value of p and q. That means alpha is 2 plus root 3. I told you the roots are conjugates of each other. So beta is going to be, yes, you're right, 2 minus root 3. Find the value of P and Q. Now, it's very easy. Alpha plus beta is nothing but minus B by A, which in this case is minus B is P, so it's going to be minus A is 1 minus P by 1, and 2 plus root 3, which is alpha, plus 2 minus root 3. So root 3 minus root 3. Hence, you're getting P as minus 4. So we're getting the value of P as minus 4. Then, alpha into beta is going to be C by A. C by A is nothing but Q upon 1. And alpha into beta is 2 plus root 3 into 2 minus root 3. Now this is again of the form A plus B into A minus B. Hence it becomes 2 square 4 minus root 3 square is equal to Q. Now this is 4 minus 3 is Q. Therefore Q is 1. So we have P as minus 4 and Q as 1. So the value of P and Q are minus 4 and 1. So among these it's this, no, not this, not this, it is this. So again we are using the concept of sum of roots and difference of roots and product of roots. I'm so sorry. Yes, and we do have minus 4 and 1 over here. Right, we jump over to the next question. These sums are quite quick and simple, so try to do these kind of sums in a limited amount of time. It will give you a better kick. You will feel good that you're able to crack it in a shorter period of time. Okay, so we have next, what we have next is, okay. Now here it says again, one root of the equation x square minus 2 bracket 5 plus m into x plus 3 bracket 7 plus m is reciprocal of the other. In other words, the roots are alpha and 1 by alpha, or beta and 1 by beta. So, we use a principle that the product of the roots alpha into 1 by alpha is nothing but c upon a, which means this is 1. So, c in this case is going to be 3 bracket 7 plus m c upon a 1 is equal to alpha into 1 by alpha, that is 1, is equal to 3 into 7 plus m will turn out to be 1. Alpha into 1 by alpha. Now we cross multiply, get 3 into 7, 21, plus 3m is equal to 1 into 1, 1. So 3m is equal to 1 minus 21 minus 20. So m turns out to be minus 20 upon 3. So again we're using the simple concept of reciprocals. I mean the reciprocal process, and the product is c by a. Just substitutions. And hence among them the value is, yes, minus 20 by 3. And yes, we have it right. From here we move over to the next one. Let's see what we have next in hand. And we have, okay, now we have a question which looks a little complicated, but actually we can tackle it. Pretty simple. Keep a paper and pencil in hand. If P and Q are the roots of the equation x square minus bx plus c is 0, then what is the equation whose roots are PQ plus P plus Q and PQ minus P minus Q, P plus Q, minus P minus Q, which is the same as minus P plus Q. Now here, if you see, in this case, PQ, for the given equation, P and Q are the roots. So PQ in this case is going to be minus B by A. So minus of minus B by 1, which is going to be B. I'm sorry, there is a mistake here. I've done a mistake here. We need to rectify this. So PQ is not that. PQ is the product of the roots. The product of the roots is going to be C by A. Right. Now, P plus Q, that is for the original equation, p plus q is minus of minus b upon 1, which is b, and product of the roots, that is pq, is going to be c upon 1, which is c. Now the new equation has the roots so and so. So the new equation's roots are alpha is going to be pq plus p plus q. Pq is going to be c plus p plus q, that is c plus d, and beta, that is the other root of the new equation, is pq. Minus p minus q can be written as minus of p plus q, which is going to be pq is c minus p. So for the new equation, the roots are c plus b and c minus b. Now we know the new equation is going to be x squared minus sum of its roots. Remember, the roots of this are alpha and beta, but the original ones are p and q. So alpha plus beta into x plus alpha beta is equal to 0. So it's going to be x squared, alpha is alpha plus beta, which is going to be alpha is c plus b plus beta, that is plus c minus b into x, plus alpha beta, that is c plus b into c minus b is 0. This will turn out to be, this gets cancelled, so it's x squared c plus c 2c, so minus 2cx, plus x plus y into x minus y is x squared minus y squared. So our guy is going to be x squared minus 2cx. Is it this? Is it this? No. Our option is going to be D. And let's check. Yes, right. We do have it right. Okay, so we have this as a solution, which is tallying with what we have in hand. Here we have is, if one of the roots of the equation x squared plus px plus a is 0 is root 3 plus 2, then the value of p and a is that. That is, alpha is root 3 plus 2. We'll put the rational part first and then the irrational, because otherwise you'll be tempted to write it as root 3 minus 2, but actually it's 2 alpha. If it's 2 plus root 3, beta is going to be 2 minus root 3, not root 3 minus 2. We have to put the plus minus sign in front of the irrational part. So alpha and beta are this. Value of p and a. Now if you see, alpha, we have done this type of sum. We'll do a quick recap. Alpha plus beta is nothing but minus b by a. Alpha plus beta is 2 plus root 3. Plus 2 minus root 3 is minus b by a. In this case, it is going to be minus p by 1 minus p. So root 3 minus 3 get cancelled. So 4 is equal to minus p, which means the same as p is equal to minus 4. Then alpha into beta is going to be c by a. Now here a is c and c is the same as a and a is 1. So it's going to be just c by a, that is a by 1, a. And this is going to be 2 plus root 3 into 2 minus root 3 is a. So a is equal to 2 square 4 minus 3, which is 1. So p is equal to minus 4 and a is 1. I think we did the same sum earlier, but in a different format, of course. The variables were different. So p is minus 4 and a is 1. So it's going to be this. This is the option we have in hand. And yes, we do have it this. And from here, the next that we have is, yes. Fine. So this is just one step ahead. We need to form the quadratic equation. Now here we have alpha is 2 plus root 5. So beta is going to be 2 minus root 5. Hence alpha plus beta is going to be 2 plus root 5 plus 2 minus root 5, which is 4. Alpha into beta is 2 plus root 5 the whole square, 2 plus root 5 into 2 minus root 5, which is going to be a plus b into a minus b, 2 square minus root 5 the whole square, which is 4 minus 5, which is minus 1. So alpha into beta is this, alpha plus beta is 4. Our equation is going to be x square minus of alpha plus beta into x plus alpha beta is equal to 0, which is the same as x square minus of alpha plus beta is 4, so minus 4x plus alpha beta, which is minus 1 is 0. So our equation would be this, provided one of the roots is 2 plus root 5. So among these, yes, this is going to be the correct answer. That is x square minus 4x minus 1 is 0, and yes, we have got it right. Furthermore, what do we have in our kitty? We need to check what we have next is this. Okay, this is also concerned with roots. Now it says that if the root of the equation, one root precisely of the equation x square minus 8x plus m is 0 exceeds the other by 4, then the value of m is what? So in other words, alpha, if one root is alpha, the other one is going to be alpha plus 4. Exceeds the other means either you take one root as alpha and the other one as alpha plus 4. In that case, it is a smaller roots, or you take it as alpha and it is going to be alpha minus 4. It doesn't matter much. Then the value of m is so and so. So either we can say alpha plus 4 is equal to minus b by 8. That is minus of minus 8 by 1. 8. And hence we get the value of alpha and so. But here it involves m. So we do it this way and then move further. So you end up getting 2 alpha is equal to 4. Therefore alpha is going to be 2 and alpha plus 4 is going to be 6. That means the roots are 2 and 6 if you solve this. But we also know that product of roots, that is root 1 into root 2 is c by, that is m by 1. So that means 2 into 6 is equal to m. Therefore, m is turning out to be 12. So the value of m would be 12. There are two ways of doing it, this way. Or else we can say alpha bracket alpha plus 4 is equal to m by whatever it is, and from that we find the value of m. Better would be to find the value of alpha individually and then substitute it in terms of m. And hence you're getting m as 12. So yes, and we do have m as 12. The next situation we have here is this. Okay. Now this is going to be a very interesting sum, and keep your papers and pencil in hand, pen, pencil, whatever. P is not equal to Q. P square is equal to 5 pi P minus 3 and Q square is equal to 5Q minus 3. The equation having roots as P by Q and Q by Q is what? Now we'll just keep this equation ready. So the equation is going to be x square minus sum of the roots, that is minus P by Q plus Q by P into x, plus product of the roots, that is P by Q into Q by P is equal to 0. This obviously becomes 1. So ultimately the equation is x square minus P by Q plus Q by P into x plus 1 is 0. This is the equation we have. But this is not the form in which we want. We want it in terms of actual numbers. So let's consider this equation P square is equal to 5P minus 3. We'll do for 1. The same would be valid. So this will turn out to be P square minus 5P plus 3 is 0. So we have to actually solve it. So alpha x, in this case P is going to be minus B, that is minus of minus 5, plus root B square, that is minus 5 square, minus 4 into A, that is 1, into C, 3, upon 2A, that is 2 into 1, that is 2. This turns out to be, P will turn out to be 5 plus or minus 25 minus 12, which is going to be root 13 upon 2. 5 plus or minus root 13 by 2. Now, if you see this equation also has the same coefficient. This is q square minus 5q plus 3. So even this is q is also going to be 5 plus or minus root 13 by 2. Now the problem arises, there is one more condition, that p is not equal to 2. Now we have to choose, although 5, root 13 and all are same, p and q are not equal. So obviously p is going to be 5 plus root 13 by 2. In that case, q cannot be 5 plus root 13 by 2. You'll have to take it q it as 5 minus root 13 by 2. I hope you understood what I did right now. We need to solve these two equations. If you see, both these equations would have the same solution, 5 plus or minus root 13 by 2. That's when we need to intersect it with this condition that p and q are not equal. So one of them should be taken as 5 plus root 3 by 2 and the other one as 5 minus. Now which among these you're going to take as plus and which is minus root 13, it doesn't make any difference. Now these values will be substituted over here. So hence this equation becomes x square minus p by q. P by q is going to be, say p is 5 plus root 13 by 2 divided by q, that is 5 minus root 13 by 2. If you see, if you reciprocate it, 2 is bound to get cancelled, plus q by q, that is going to be 5 minus root 13 by 2 divided by 5 plus root 13 by 2 into, this also 2 gets cancelled, x plus 1 is 0. This on simplification would become x square minus 5 plus root 13 upon 5 minus root 13 plus 5 minus root 13 upon 5 plus root 13 into x plus 1 is 0. Now here, how do we simplify this? We need to take the LCM. Now this will hence become, you can take the LCM, 5 minus root 13 into 5 plus root 13 is the LCM, which can be written as 5 square minus root 13 the whole square. So you simplify it, a minus b into a plus b. Then this divided by this will give you 5 plus root 13 the whole square in the numerator. This divided by this will give 5 minus root 13, so it becomes 5 minus root 13 the whole square into x plus 1 is 0. This would now become x square minus, now this is of the form a plus b the whole square plus a minus b the whole square, which will turn out to be 2 times a square. If you open the bracket, even if you open the bracket, the 2ab term will get cancelled. So it's going to be 2 times a square, that is 2 times 25 plus 2 times b square, that is 2 times root 13 the whole square. Because there is going to be one 5 square here plus this 5 square, root 13 square and this root 13 square, and then there is a 2 into 5 into root 13. And here there is minus 2 into 5 into root 13. They will get nullified. This thing into x plus 1 is 0. Denominator is 25 minus 13. Now, this you need to simplify. So this becomes x square. And this will become 2 into 25 minus 50. And 2 into 13. That is 26. Minus of 50 minus 26 upon 25 minus 13, sorry, 50 plus 26, I'm sorry, upon 25 minus 13 is 12, x plus 1 is 0. Now if you simplify this, this will become 76 by 12, which eventually would become x square minus 76x upon 12 plus 1 is 0. You cancel by 4, this becomes 3, this becomes 19. So you get x square minus 19x by 3 plus 1 is 0. So I'll just take this over here. This particular equation, I will take it here. Here we have it. So ultimately it's x square minus 19x upon 3 plus 1 is 0. And if you multiply throughout by 3, you get 3x square minus 19x plus 3 is 0. So this is going to be our final equation. 3x square minus 19x plus 3 is 0. So among these, this is the right option. So I'll just explain it once more. We need to find the equation whose roots are p by q and q by q. So once you know this is alpha, this is beta, the equation is x square minus alpha plus beta into x plus alpha beta. This on simplification becomes this, but we need to individually find the value of p and q. We solve one of these and you get this, you get the value of p as 5 plus or minus root 13 by 2. Since the equation containing q also has the same, exactly same coefficients of q square, q and the constant term, even its solution is going to be 5 plus minus root 13 by 2. But it is also told that p and q are not equal, hence if one of them is taken as 5 plus root 13 by 2, the other one will be taken as 5 minus root 13 by 2. If you see, if you're interchanged over here, p and q, even then the value would not have changed. So there is absolutely no scope for any kind of confusion as to what you should take it as p, 5 plus root 13 or 5 minus root 13 by 2. Furthermore, it's just being careful about how to simplify the equations, and ultimately we get 3x square minus 19x plus 3 is the solution. That is option number C, and yes, we do have it right here. Right, so that was a slightly interesting one. Of course, you need to have worked upon it. It's balanced either ways.